Hi again. So let's talk about projectiles, just you and me. It's another type of two-dimensional motion where previously we looked at most things on the surface of the Earth, X and Y being on the planar surface here. We're going to look at X and Y this way now. So horizontal surface of the ground is going to be X, Y is going to be vertical. And the nature of vectors still apply. Think of what happens if we look at X and Y vectors in terms of, does this vector affect this one? Remember that from the stream crossing. If we start to look at what a projectile actually is, if something is launched or is in the air above the Earth's surface, if there's no other force acting on it, no other propelling force on it, that is considered a projectile. If it's in the air on its own and gravity is in the driver's seat at that point, that's a projectile. Anything that is in the air and is being propelled is not considered a projectile. So examples of projectiles would be baseball having left the barrel of a bat, traveling out into center field. Field goal kick, once the football leaves the laces of the kicker, water leaving a hose. You can chuck it into the air and let it fly, it's going to be a projectile. A lot of the concepts that go with projectile motion sometimes are counterintuitive. So typically we start with a couple of demonstrations that try to drive a couple of key points home. And what I want to show you is one of the mechanisms that we use for one of the initial demonstrations. And that'll be followed up by an actual demonstration to show the particular aspect of projectiles I'm trying to get across here. So if I bring this up so you can see this. This is a launcher, and it is designed with a piece of metal that has two spots where you can place these ball bearings and they'll rest fairly comfortably. Now this is designed so that when this is on a flat surface, both of these objects are at the same elevation, same height above the ground. But what happens is there's a spring holding back the arm. So if I depress the spring, now let's look at it this way. So if I depress the spring, what it's going to do is it's going to send this ball bearing straight ahead. So it's only going to have horizontal velocity when it leaves. On this side of the launcher, where the spring is, this is going to pull back when this thing is horizontal. Now what that's going to do for this ball bearing is, because of the structure, when this pulls back, remember Newton's law of inertia, there's not a lot of friction here. So when this pulls back, the ball just falls straight down because you've removed the support force, and now the gravitational pull is able to manifest itself and have it fall, say, quoted free fall. The challenge is going to be is, what would happen if I took a ball bearing here and a ball bearing here, same height above the ground? When I do this, at the same time, one ball is going to drop straight down and the other ball is going to launch forward with a certain horizontal velocity. The question is going to be, how does the time it takes the ball to drop straight down compare to the time it takes the ball that's being launched horizontally to fall and hit the ground? So I want you to think about that, and then we'll load the second video, which is going to show this in slow motion. And it may surprise you. I hope it does. So I'll be back in a few.